So my goal today is to teach you how to name binary ionic compounds and to make it easy. Here's an example of an ionic compound right here. This is a salt crystal. So ionic compounds are generally crystalline solids at room temperature. They have very high melting points and they form very strong bonds. But our goal today is to learn how to name them. Before we name them, let's look at all the categories of solids. There's way more than just ionic and molecular solids. There's also atomic solids, and atomic solids can be broken up into network solids like diamond, metallic solids, you see metals all day long, and then solids that form from some of the atoms in group 8A or the noble gases group 18. But today and for the next 3 lessons, we're going to focus on ionic solids. Bonds form in atoms based on 2 features, according to the number of valence electrons that an atom has and where on the periodic table that atom or element is. Now, in prior lessons, you've learned that valence electrons are those outside electrons, and those are the electrons that are involved in bonding. So, if an atom gains, loses, or shares its electrons, it determines whether or not the bond is ionic, covalent, or metallic. Since we're focusing right now on ionic bonding, we're going to talk about gaining and losing electrons. Now, it makes sense that if something loses negatives, if you have a negative person at your house and they walk out of your door, you're going to feel positive. So it makes sense if you're losing electrons, you're going to form a positive charge, and if you're gaining electrons, you're going to form a negative charge. Now on the periodic table, metals, and all of these guys right here are metals. Metals lose electrons, and when they lose electrons, they form a positive charge. Nonmetals gain electrons, and they form a negative charge. So, what is an atom trying to achieve by gaining or losing electrons? The reason why atoms do this is because they're seeking stability. They're looking for a more stable state. So, atoms with full outside shells are said to be stable. The octet rule, or the rule of 8, means that when an atom has 8 outer electrons, it is stable. And those stable guys would be these guys right here, the noble gases. The noble gases have 8 electrons in their valence or outside shell, and because they have 8 valence electrons, they are stable, and it's very hard to make them bond with anything because why should they? They already have everything they need. However, I kind of lied to you because we have helium right here, and helium only needs 2 to be stable. In fact, some atoms only need to follow the duet rule. They only need 2 electrons in their valence outside shell in order to be stable. 5 atoms on the periodic table are like this: hydrogen, helium, lithium, beryllium, and boron. They just need a stable duet in order to have their outer shell full. So when you learned electron configuration, you learned that every one in group 1 has 1 valence electron. You learned that every atom in group 2 has 2 valence electrons. You learned that every atom in group 13 has 3, group 14 4, 5, 6, 7, this is 2, and everybody else here is 8. So those are the valence electrons. Now remember, everybody's goal is either to have a stable duet or a stable octet. So how are they gonna achieve it? Well, if you're in group 1, you're gonna lose an electron. You're gonna lose this electron, and you're gonna get a +1 charge. If you're in group 2, you're gonna lose 2 electrons, and you're going to get a +2 charge. If you're in group 13, you're going to lose 3 electrons, and you're going to get a +3 charge. Remember, if 3 negative people leave your house, you're going to feel happy 3 times over, +3. Group 14 elements usually covalently bond, but for ease, we say they either lose or gain 4. Group 15. Group 15 is almost, they have 5 valence electrons. They almost have 8, so they only need to gain 3 more. So they're going to gain 3 electrons. When you gain 3 negatives, your charge is -3. Group 16, they only need 2 more to get to 8, so they're going to gain 2 electrons and have a charge of -2. Group 17, they have 7 valence electrons. They only need to gain 1 electron, so they're going to gain 1 electron to get a -1 charge. And group 18 do not form ions because they are stable. They don't need nobody. So, if you understand electron configuration and stability, you will then understand why elements become positive or negative. If you don't understand that for now, you need to memorize group 1 + 1, group 2 + 2, group 13 + 3, group 15 - 3, 16 - 2, 17 - 1. And now you are well on your way to understanding how to write an ionic compound. So all of these guys on the left side are metals, and everything on the right side are nonmetals. And metals lose their electrons to become positive cations, and nonmetals gain electrons to become negative anions. So cations are generally metals, and anions are nonmetals. When we're naming, the metals keep their name. An ionic bond is made up of a metal plus a nonmetal. So it's made up of a cation plus an anion. The anion changes its ending of its name and it ends in IDE. So chlorine becomes chloride. Oxygen becomes oxide. Nitrogen becomes nitride. Phosphorus becomes phosphide. Iodine becomes iodide, and if iodide, then we are very sad. Sulfur becomes sulfide. Bromine becomes bromide. Chlorine becomes chloride. I think we got them all. So they all get that IDE ending. The cation keeps its name, so thus we would have lithium oxide, or we would have sodium chloride. Oh, salt, you had a lot of that already today. K would be potassium nitride. And you've heard some of these names before, and that IDE ending is because the anion gets an IDE ending. So now we're ready to write binary ionic compounds. I'm going to quickly go in and I'm going to put my charges in. And here I'm ready to go. Binary means 2, ionic compounds. Ionic is a metal plus a nonmetal. Binary means there's just one metal, one nonmetal, and here we go. So how do you do it? You write the cation, you write the anion, you balance the charges to make the total charge 0. Okay, so let's do this. Let's combine group 1 metals with group 17 nonmetals. Here we go. So we're going to combine these guys with any of these guys. Well, these are the easiest of all. Why? Lithium is in group 1, so lithium has a +1 charge. Fluorine is in group 17, so fluorine has a -1 charge. Balance the charge to make the total charge 0. +1 - 1 is already 0, so this compound is lithium fluoride. I wouldn't call it lithium fluorine. The anion gets an IDE ending, so it would be lithium fluoride. Okay, let's do another one. How about sodium? Sodium is +1, and let's combine sodium with bromine. Bromine is in group 17, minus 1. The charge is already balanced to 0, so the formula is going to be NaBr, and the name is going to be sodium bromide. All right, so based on what I just showed you, see if you can write the formula between potassium and chlorine, and then between sodium and fluorine. Pause the video, write those. Okay, so you should have gone potassium plus 1, chlorine minus 1, balances out to 0, KCl, potassium chloride. Na and F, sodium is in group 1 plus 1, fluorine group 17 minus 1, balances out to 0, NaF, sodium fluoride. Very easy combining group 1 with group 17. What if I wanted to combine group 1 with group 16? Well, I've already memorized group 1 has a plus 1 charge and group 16 has a minus 2 charge. So let's say I want to combine lithium and oxygen. Well, lithium has a plus 1 charge, group 1. Oxygen has a minus 2 charge, group 16. Obviously now these charges do not balance out to 0. So what do I need to do? I need another lithium. Because if I have another lithium, now my charges balance out to plus 2 minus 2, which is 0, and that was my rule. Combine the cation and the anion, balance the charges to 0. But now what happens? How many lithiums do I have? I have 1, 2 lithiums. How do I show that in my formula? I'm going to write Li subscript 2 O. Now notice a few things. The subscript is part of the formula, lithium oxide. The charges go away. We use the charges to tell us how many we need and to get it to balance to 0. Once we've done that and it's told us that we need 2 lithiums, we are finished with the charges. Don't ever put charges in your final answer. Remember also when you write charges that they are superscript. I always tell my students charges are in charge, put them on the top. Subscripts are part of the formula, sub at the bottom. Subway, sub at the bottom. How about we combine sodium with sulfur? Well, sodium is in group 1, so its charge is plus 1. Sulfur is in group 16, so its charge is minus 2. Once again, the charges do not balance out to 0. I'm going to need another sodium. And now my charges are plus 2, minus 2. So now I know that I need 2 sodiums for every 1 sulfur to get the charges to balance out to 0. So my formula will be Na2S. How would I write that? It would just be sodium sulfide. You don't mention the 2 in the final answer. It's just there. Some students want to write disodium sulfide. No, save the di, monos, and tris for covalent bonding, which is another video and another type of naming. Okay, what if you wanted to combine potassium with oxygen? All right, potassium charge is plus 1. Oxygen's charge is minus 2. We're going to have another potassium to give it a plus 1 charge. So now it's going to be plus 2 minus 2. We've achieved our goal. We've balanced it out to 0. So how many potassiums do I need in this compound? I need 2 of them. I show that with my subscript K2, 2 potassiums, 1 oxygen. This thing is called potassium oxide, IDE ending. All right, how about you do these 2 on your own? Lithium and sulfur, sodium, and oxygen. Okay, your completed answer should have been Li2S and Na2O. This one here is called lithium sulfide, and this one here is called sodium oxide. Okay, so now we know how to combine all group 1s with all group 17s, all group 1s with all group 16s. Let's combine group 1 with group 15. So now we're going to combine group 1 with group 15. So we're going to combine plus 1s with minus 3s, and I bet you can guess what's going to happen. Let's combine lithium with nitrogen. Well, lithium has a +1 charge. Nitrogen is in group 15 and has a -3 charge. So I am going to need 3 lithiums to balance it out to 0. So what's my final answer going to be? Li3N. What's its name going to be? Lithium nitride. Do I use the 3 in the name? Do I say try something? No, not for ionic bonds. Do I have a charge in my final answer? No. The charges are simply to tell you how many lithiums I need. I need Li3. I need 3 lithiums. Now, I know you've noticed the pattern by now, so you pretty much know that anything from group 1 is going to combine with anything from group 15 in a 3-to-1 ratio. So if I wanted to combine, for example, we'll do 2 more here. If I wanted to combine sodium with nitrogen, I would need 2 more sodiums. Balances out to 0. So this is going to be Na3N. What's its name going to be? Sodium nitride. How about you try potassium and phosphorus? Potassium and phosphorus. Okay, you should have gotten K3P, and its name is potassium phosphide, IDE ending. So now we know how to combine group 1 with group 17, group 1 with group 16, group 1 with group 15. Moving on, let's combine group 2 metals with group 17 nonmetals. Okay, so we're going to pick a group 2 metal and a group 17 nonmetal. And let's pick calcium. Group 2 is +2. With a group 17, let's pick chlorine. Now, what do we have to do to balance it out to 0? I need another chlorine. +2 -2, CaCl2. What's it going to be? Calcium chloride. And you see as you go along how easy this gets. How about if I wanted to combine a group 2 metal with a group 16 nonmetal, okay? Well, let's use calcium again for my group 2 metal. And let's use oxygen for my group 16 nonmetal. Oh, and now it's already balanced again. +2 -2 is 0, so we don't need any subscripts in our final answer. And this is going to be calcium oxide. Okay, how about we combine group 2 with group 15? So let's go up to group 2. Let's pick magnesium for our group 2 with group 15. Let's pick nitrogen for our group 15, okay? So magnesium is +2, nitrogen is -3. Now we have a problem. We have a 2 and a 3. Well, I like to tell my students, if you have a 2 and a 3 in chemistry, put a 3 and a 2. Let me show you something that you could do here. all you would have to do is put this number 3 here and put this number 2 there, and your final answer would be this. But why? Why is that correct? Well, we have to balance out the charges as we've been doing all along. Okay, so if I have 2 on this side, I'm going to need a total of 6 on this side and 6 on this side, which gives me plus 6 minus 6, which balances the charges. And then looky there, I have 1, 2, 3 magnesiums and 1, 2 nitrogen. So it's easy when you have a 2 and a 3 just to switch the numbers and have a 3 and 2, but it's important to understand that you're still balancing the charges and you're still logically thinking through this. Let's do another group 2 with group 15-1. I'm going to supply them and then I want you to try it on your own. So we're going to pick for this one calcium and phosphorus. Calcium and phosphorus. So you try that one on your own. All right, hopefully you landed up with this. How did you do it? Ca is plus 2, group 2. Phosphorus is minus 3, group 15. I'm going to need 3 calciums to give me a plus 6 charge and 2 phosphoruses, if that's a thing, to give me a minus 6 charge. So it's going to be Ca 1, 2, 3, P2. 1, 2. You're like, hold up, Miss Arrington. What about that switcheroo thing you did? Okay, you can do it that way. Ca plus 2, P minus 3. Switch the numbers. Ca3, P2. Same answer. Make sure you understand why, though. Let's now try any group 13 with a group 15. Group 13, and let's pick aluminum with a group 15 with nitrogen. Aluminum with nitrogen. And I bet you know what to do. Aluminum is plus 3, nitrogen is minus 3, and guys, it's already balanced. So ALN. Done. Now you may say, well, wait, I like that switcheroo thing you did. Can I just switch the numbers and write Al3N3? Well, you can, but you're not correct because you have to reduce to the lowest ratio, and that's a 3 and a 3, so that becomes a 1 and a 1. So be careful with the switcheroo thing. If your charges are balanced, you only need 1 of each. So just be careful with shortcuts that they don't mess you up. All right, now let's try group 13 with group 16, okay? We're going to come up here, and for group 13, we're going to pick aluminum again, and group 16, we're going to pick sulfur. So aluminum and sulfur. Al is plus 3, sulfur is minus 2. Group 13 and group 16. Now do you see? Hey, remember when you have a 3 and a 2, put a 2 and a 3. You can just switch these numbers. So this is going to become Al2S3. Aluminum sulfide. Remember, you're never going to say dialuminum trisulfide. Ionic compounds do not use mono, di, tri, etc. Now, let's just show this out by balancing the charges. Al plus 3, S minus 2. I want this to balance out to plus 6, minus 6, so I'm going to need 2 more of these. And that's why I have 1, 2 aluminums and 1, 2, 3 sulfurs. Use the shortcut, but make sure you understand why you're doing what you're doing. So congratulations, you have basically made nearly every binary ionic combination on the periodic table, or at least all the common ones, and we've got this. I've left you with 6 to practice. Pause the video and try it on your own. And I threw in a 7th one, calcium phosphide, And here's the answers: NaCl, AlCl3, AlP, MgO, Li2S, K3n, Ca3p2. It's harder to go from this way to this way, but sometimes your teacher will give you this and then tell you to go back. All you're doing is adding an IDE ending. You don't use anything with the subscripts in the name for an ionic compound. And now you know how to write binary ionic compounds